welcome our honorable dignitaries for industry expert lecture on automation in heavy industry, organized by the Students Activity Cell of Dnyanshree Institute of Engineering and Technology, Sitara, under Vikasit Bharat at 2047. I want to welcome Honorable Mr. Head of Heavy Industry Business at Mitsubishi Electric India, Honorable Mr. Vikasit, Managing Director, Dnyanshree Institute of Engineering and Technology, Sitara, Honorable Mr. Ajay Sadhav, Principal, Dnyanshree Institute of Engineering and Technology, Sitara, Professor S.M. Patil, Coordinator, Students Activity Cell, Dnyanshree Institute of Engineering and Technology, Sitara. I do extend a warm welcome to all head of the departments, faculty members, and student participants for the program. To mark the beginning of our program, I formally invite the honorable dignitaries to offer tribute to Bharat Saraswati, the Goddess of Knowledge. In 1989 as an application engineer. After working for 4 years in application department, he moved to control technique as application in charge for drives. In 1999, he has joined Nissan System to work for business development of Mitsubishi Drives. He is actively involved in pan-India business development, Mitsubishi Drives. In his current position, head of heavy industry business, Mitsubishi Electric India from 2018. He is responsible for developing business in various application sectors like steel, sugar, pepper, and cement. With his huge experience in dried products, he has his involvement with Mitsubishi Japan for development of new products. So it's an honor, sir, to have you here today with us at Dnyanshree Institute of Bharat students. So may I request Honorable Mr. Vikasit, Managing Director of Dnyanshree Institute, to felicitate our guest of honor, Mr. K.T. coordinator of Students Activity Cell, to give a brief introduction to this program. Sir.
Good morning, one and all. Respected dignitaries of the dais, today's resource person, Chogule sir, our managing director, Rohit sir, our principal, Dr. A.D. sir, our head of the departments, faculty members, and my dear students. As we know that India is turning point in the history. This is the 21st century will be the India's century, and today India is the largest economy in the world, and it will be world's third economy by 2027, and it will be the achieve Vikasit Bharat in 2047. The Vikasit Bharat at 2047 is the vision of government of India to make India a developed nation by 2047. The vision encompasses various aspects of the development, including economic growth, social progress, environmental sustainability, and good governance. Ambedkar Vikasit Bharat at 2047 is a visionary program aimed at transforming India into the developed nation by 2047. As designed by the Prime Minister Office, Ministry of Education, Government of India, and AICT has a planned series of seminars in selected campuses throughout the country, where the experts from the industry, academics, administration, sports, and public services gather to share their knowledge and insight that having remarkable contribution towards the country's development. And it is proud to say that our institute is one of the institutes to host such type of the program. And on behalf of Dnyanshree Institute, I am very much thankful to Chogule sir for support accepting the invitation and supports for the conducting such type of the event. In the continuation, I want to say to the students, education is not limited to the academics. Vikasit Bharat emphasizes holistic development, nurturing values like critical thinking, creativity, and collaboration. So, thank you, and let's begin on the journey towards Vikasit Bharat. Jai Hind.
So, what is the point? Honorable Speaker, Mr. P. Chogule sir, to address our audience. Sir.
Good morning. Actually, thank you and sir, we are organized session. Actually, this is my third time this work. When sir has brought me regarding this great time, immediately I will come and do the lecture. Because this college is at the rural area, I want to, whatever I have learned in my total career, I want to give you some of the highlights of that, so that you are studying the books, real what is there in the industry, you can understand. And here, particularly, I am giving the lecture on the heavy industries, and where I am giving this heavy industry business specifically for all areas. So on that same subject, I am giving the lecture. Actually, I have started as a lecturer only in Hong College in 88. 1 year I have done the lectureship, and after that I have thought that I should go into the industry. And after doing the industry work, now I feel that I should give some of my knowledge to the students who are from the rural area. That is the reason I have been called here, and I will try to do the as simple as that what you can understand. Other things are there. After the lecture, I will answer to all the queries. So, what is the heavy industry definition? I will do first. Then the market scenario, process flow, and the automation requirement in this industry, especially steel, cement, sugar, paper, and some of the special applications which are required in the early industries. Then I will explain. After that, I will give my company introduction, what my company is doing, and what are the activities my company. That I will at the last I will few slides I will explain my company. So first I will start with the definition of the heavy industry. In heavy industry, by the definition of the it comes like steel, cement, paper, and sugar. And we are doing a total automation solution along with the integration of the products to this industry, as well as to industry whatever the nominations required. Because in the industry, if you want to work your nomination for some consultants like Metron, these are the important consultants in the sectors like Metron or the Alliance. These are the consultants where we are working, and that approval is also the process of our business. And as well as we are working with different companies, NTPC, sales, JW, and explaining what are the references to what we are creating in this industry. So after this, I will just explain my team. I am heading this division, and under me in Pune there are 4-5 people are working, and all over India there are 22 people who are already reporting to me for this activity. This is my profile, so that you can understand all over India we are now come to the sectoral information. First, I will start with the steel industry. Just to look into this steel industry, we are the second largest production and consumption after the China. But if you look at the per capita consumption, our per capita consumption is 76 kg, whereas Japan consumption is more than 600 kg to China. So if we increase our per capita consumption, we will definitely cross the China. So we are near the future, we will be able to become number one in steel industry also. And in this bigger groups like JSW, Tata Steel, and SAIL, MNS, these are the groups, bigger groups are there who are working in this sector. These are the new expansions coming in the different companies like JSW, there is expansion, third phase expansion is coming. Tata Steel there is expansion, as well as SAIL. SAIL is the SAIL Authority of India. This is government company. There are also the big expansion going to come. This is all about the overview of this business as such in steel industry or India. After this, I will explain what is the process of making steel. There is upstream process and downstream process. Upstream process means from the raw material we have to create a product which can be sold for the downstream. So I will explain further slides what is the downstream, what is upstream, so that you can understand the complete process of steel. RMHS means material handling system, open center, blast furnace, steel melting shop, and continuous casting line. This comes under the upstream process. And this upstream process material goes to the downstream process, where the finished product will be prepared according to the requirement of the industry, requirement of the industry. So this is the raw material preparation upstream, and the finished product preparation is the downstream. So I will go into the detail of this scheme. This is the process as such, upstream process, where from the coal and coal and iron ore, the raw materials like billets and bars will be produced in the upstream process. I will go one by one in this process, what is meant by iron, sponge and one by one I will explain, and the steel making shop, and then the bars will be produced in the casting. And this part goes to the downstream process, which will finally prepare pipe, steel bars, wires as per the requirement of the steel. This is the total overall steel process as I have explained. I will go one by one in this process. Upstream process, these are the references what we have created in the upstream process. And one by one is the RSSM. In this mainly raw material will be used in the RSSM. This is the first process of RMHS. In this raw material will be used for the like the limestone, dolomite, and the managed, and this will be transported. This is the transport is not a small transport. It is 4-10 kilometers of transport will happen, and machine will pick the material and put it in the storage area. These are the process as such. And in this, automation requires a reliable robotic robust system are required, but this is into the outside of factory. So there will be a lot of dust will be there. So robotic robust system will be required. Quality products will be required to handle. In this, from the PLC side, some 1500 diode PLC input and output PLC along with the remote diode, because it's a long distance travel. So remote diode is there. And in the drive, from 75 kW to 600 kW drive will be used in this process. So this is the raw material handling. In this, stacker and reclaimer. These are the two products used. Stacker means stacking of the material, and reclaimer is from the stacking material to the removal material. This is stacker reclaimer. In this also the PLC automation will come. Then called as loader, wagon, tippler, and loader. Tippler, wagon, tippler means you have unloading material on the wagon, and tippler means we have to download material from wagon. So tipping of the wagon is possible. It is all the material will be traveled by wagon. So the wagon, tippler, and loader will require this. Then comes the process of coke oven. Coke oven is the process where coal will be converted into coke. by heating the temperature like 12-15 centigrade. So this process is very important process. So this is the coal will be converted to coke that is used as a raw material for the next process. So this is the just video I have shared. So this is the video of the coke plant. There are a number of batteries used there. And in this PLC automation is what we are using PLC again what 1100 diode and drives from 5.5 kilowatt to 400. So I am explaining the process, what is the automation required for that on the same slide and explain. So that you will get step by step the idea what is the automation like this. This is a project we have completed of the Coke one JSW plant. This is the iron application to supply the plant almost 76 price used in this open plant. So next process is the sinter. Parallel to Coke one, sinter is another process. Here sinter means quick iron ore and iron ore into sinter, which is the raw material required for the glass furnace. From the sinter to go to the glass furnace. Sinter is made by burning the mix of iron or substances. This is soft iron to which sinter is raw material for the glass furnace is required. So here automation required is a PLC, again a redundant PLC and drive from 5.5 to 50 kilowatt. These are the drive rating required in this process. So this is the application our company has done. The sinter along with the panel, it was not only more supply, IT requirement and compliance is also required. Whether I is being right required, IT requirement and compliance model. Then the next process in the blast furnace, the raw material of sinter and the coke goes to the blast furnace. Preparing the molten iron. So oxygen blast furnace is coke iron and limestone will continue to heated to form the liquid and pig irons. And oxygen must be removed to slowly reducing and injecting the hot air into this. Further transportation, this will go to the oxygen furnace for the this is the process of blast furnace. This side of the meter up to 1500 degrees centigrade. And more one will produce from the blast furnace. So next process is the sponge iron process, which is actually parallel process to sinter plant or coal plant. Some of the plants will not have the sinter plant or coal plant or blast furnace. These are not visible for the small companies. They will be buying sponge iron or soft iron. This is the parallel process of the sinter plant and coal plant and blast furnace. So this is the process here. In this again raw material will be there, mixing of iron ore, dolomite especially, and it will be heated. And in this conveyor PLC is required. And in this there will be pillar which will be heated. All this mixed with the 105 degrees centigrade and to produce this sponge iron. And for this accurate control of the temperature, PID control, all these functions are required in the PLC. And VFD rotary pillar will be required for the load sharing mode, because this one pillar requires two drives, not only one drive. So both the drives work in the load steering mode. Then only you can run the one cleaner with the two motors. So this is a very important feature required in cleaner. And then it will be cooler will be there. Everything will be good and create a sponge ion. And then screening and magnetic magnetic sorter will be there, so that ion will be separated here and all other impurities will be dispatched to different location. And then after that, this is their heat will be there. So when heat recovery, ESP will be there to process the parallel process to this. So this is the sponge process as such. We have created all these SCADA screens required in this. In the condition for I we have done this process between 950 tons per day is the production of this sponge iron. So this is the screens, SCADA screens produced. We have prepared, and after this I will go to steel melting. Output of iron this glass furnace and the sponge iron in some cases go to steel melting. Steel melting, there are two processes. One is the basic furnace, and another thing is electric arc. What is the difference in this? Basic oxygen furnace and electric arc furnace. This is a liquidity going from the blast furnace. Scrap is the main feed of this product, and oxygen is blown into this molten iron and reduce the carbon content from 0.4% to 0.5%. All the carbon content in the pig iron will be reducing this, and scrap will be added to control the temperature, and steam is then added to the furnace. This is the basic oxygen. Then arc furnace use high power electric arc to melt the material. Okay, oxygen furnace is melting with the oxygen, use of oxygen, here is the electric arc furnace. And in this mainly scrap steel we will use and the sponge iron we will use. This is the basic oxygen furnace comes from actually blast furnace output, and the sponge iron output here direct reduced iron is the raw material required for the arc furnace. There are two different processes. The final product will be the same, and this is the basic oxygen furnace. It is raw material will be added. Box technology, we have done this application in JSW. So then comes the continuous casting line. Continuous casting line bars will be produced in the different shapes according to the requirement. So this is the continuous casting line process with molten is solidified in the same finished product, billet, grooves and slabs. And this there will be different machines, two-stand machine, three-stand machine, four-stand machine. And these billets will be produced. These are the output of this casting line, continuous casting line. According to the requirement, round shape, square shape, whatever bars are required, that will be produced in the continuous casting line. And this, after this will go to the rolling mill. This is another important process of the rolling mill, where the billets will be put into rolling mills and it will be maintained. And then it will be converted into the state according to the requirement. So this is the process of the hot strip mill. Usually there are 4 or 5 days in the section. We run the continuously. is our simple application, but we have done in road for the projects almost 75 and 29 guys who we are used in this process of assembly. We are planning. Then comes the continuous simulation improvement packages in the rotating furnace and gears will be inserted so that you want to create a light that gears will be inserted into the automated and converted into the wire sheet. In this also multiple PLCs are required. Multiple PLCs with the different capacities are required in this process. These are the screens, SCADA screens we have produced to gears and view and use for this process. And then comes the annealing and painting knife settling knife. After the final product is prepared, as you know, the annealing steel is used for the use and all the things, and coated steel is used for the use nowadays. So final product will be made on the line application, where the one unwinder will be there and one divider will be there. And this coordination between unwinder and divider is very important in this. Actually, unwinder, because in unwinding, this speed should reduce, unwinder speed should increase when winding comes, diameter comes down. And unwinder speed should decrease when the winding, so surface speed will be faster. So this is very important feature required in automation. Because one only material, one side is unwinding, one side is rewinding. So you have to keep the surface speed constant. So that for that process, gradually you should increase the speed of unwinder and decrease the speed of winder, because winding is different. So this is very important feature. Another thing is the winder is always in the rotating condition, and unwinder is always in the regeneration. So both the drives are acting differently. One is rotating, one is regeneration. So you have to be there, have the common DC bus, so that unwinder rotating regeneration will be used by other drive of motoring. So energy will be saved. That is the reason one regenerative drive will be regenerative unit will be required. On that DC bus, you have to put the unwinder and winder. So unwinder energy will be fed back to the system, and winder will be using that system in the same system. This is very important technology required when the line application. Either it is paper, either it is steel. This is a very important feature required when it comes to the line application. So these are the control systems. Very high frequency is required in this, with the CC-link communication and high-speed communication required. But this is a very fast process, and you have to precisely control the speed of the drive. Otherwise, one drive will take, but another drive is pulling very hard. So this is very important thing. Then with this, I will end my presentation on the steel industry. Now it comes to the cement industry. Cement industry, we are second for largest after the cement, after the China. Okay, and demand of India is now increasing. So earlier, Ultratech cement is leading. Nowadays, because of the takeover by the Adani Group, ACC Cement and Ambuja Cement, these two plants have been taken over by Adani Cement. So now Adani is number one in the cement production. So this is the story of the background of the cement industry, and here the process, complete process has been explained. One by one I will take you the process, how it is there. It is more or less similar to the steel industry, so we will quickly go into this. Again, in the various storage and mainly will be there, like the steel industry, raw material, yard handling system will be there. Then comes the automation required, again a robot system which is outside the factory, so you should be having proper high quality products will be required in this. And in this raw material handling, again raw material handling will be the limestone and other products will be there, the raw material handling. Then you will go to the, this also requires a control system of the technical redundancy PLC of equipment and high voltage of 400 kilowatt raw material handling. And then go to the hydraulic. This is a very important feature again, like sponge and safety pillar will be there, high capacity drive will be there. This mostly 690 volt drive will be required in this requirement. 650 kilowatt drive is required in this killer application. That would not be one drive, there will be two drives there to have a killer. And temperature control is very important in the killer application. So that process is required. in this to control the temperature, especially generally DCS will be required for high capacity input of sugar to the required in the system. Then comes the grinding. After this heated metal, it will be grind it and added with gypsum and added material to prepare a cement and powder. So this is the process of grinding, and here also automation is required. And I will see and live from 22 this is the application required. And packaging, this material will be stored in packaging. Packaging will be last process of this system, where the small PLC required 400 hours, and I will try from 50 kilo to 50 kilo. Because packing material conveyor will be there for the 50 kilo to 50 kilo. Then the capital power plant, as it is heating generated in the kiln, that will be used to run the captive power plant, which can have the internal power consumption will be used to for the system, as well as the environment is very important thing nowadays. The environmental monitoring and all the things are required under the total system. This is a greenfield project what we have commissioned recently, and Voltaic is a consultant in this. As I told you, there are different consultants in different sectors. That is a very important role play important role in any of the projects. These 69 plants we have commissioned in this project. Then comes the sugar industry. This is a very important industry, as you know. In our area, the sugar industry is the biggest. We are now largest sugar manufacturer, and we have surpasses the Brazil. Earlier, Brazil, last 2 years back, Brazil was the topmost sugar manufacturer, but now India has surpassed the Brazil. Now we are #1 producer of this. So, and third largest exporter of sugar. So there are two opportunities nowadays. One is the, as you know, 20% of ethanol you can use in the petrol nowadays, guidelines and so on. So there is a 15% of sugar cane now used to produce the ethanol. So this is a very important feature and important news, and there will be a lot of scopes are there. A lot of sugar factories, Maharashtra, Western, Uttar Pradesh, these are the major areas where the Praj and these are the companies which are working on ethanol plant. So this is another new thing is that now 60% of jaggery used in the world is produced by India. So this is another opportunity in the sugar industry. Instead of sugar, now people, because of the implementation of the sugar increasing this people are shifting to jaggery. So 60% of the jaggery was newly all over the world is produced by India. So this is another opportunity. There are single volumes are there for making these jaggeries. These are the, as far as the industry is concerned. What is the process again? Again process. One is the cane feeder. Whatever canes come from the farmers, it will feed it properly into the system. There is cane feeder. Here also PLC and drives. Then comes the mill, where the actually sugar cane will be crushed and used to be extracted from that. So these are the rollers will be there. 3 to 6 rollers will be there in that the sugar is crushed. And then the process, these are the speeds of the sugar mill process. So after this, then there will be juice preparation area. This is important to produce the sugar. After the juice is prepared, it will be there and proper sugar will be produced. And then the pan crystallization. Then pan application will be there. Vacuum pan especially heat the exterior and juice from the concentrated sugar. And then this is the process flow for the required for the juice preparation of the thing already there that is application. So another important is the application after the juice production and crystallization. Important feature is required in centrifugal. This is a very critical application because motor will be mounted at the top and the basket is at the bottom. And with the centrifugal action, all the liquid will be removed from the molasses and the proper crystallization of the sugar is possible. In this, what will happen actually? In the acceleration, it will go to the 12 RPM acceleration, then it constant speed, and then at the time of acceleration, a lot of regenerative energy is required. In that case, you have to use either DC drive or regenerative drive, or you have to have the regenerative drive which can take care of this regeneration what is happening in the acceleration. This is the regenerative unit that is required. So this is the packaging process as seen like cement and other processes where also is required. Then the cogeneration is the power plant is generally available where the gas is used as a raw material and the automation required for a PLC. This is the some support we have done most of the plants for automation because of the plant and this application almost 83 years has been used in this. So then comes paper industry. Major paper industry in Uttar Pradesh, Gujarat, Karnataka, and Maharashtra. As plastic is banned, now paper consumption is increased. So there is a lot of scope. Now paper industry is going very hard. Here also pulp preparation, first in the raw material, take the raw material and add to prepare the pulp. And screening will be added, advanced processing will be done. Then this part is also required from PLC of higher drive and energy efficient drive for the electrical application required this. Then comes the sectional. This is very important line application because one only paper goes with all the rows and you have to keep all the surface speed of all the rows same. So this is a very critical application and paper is very thin material. So any disturbance in the speed synchronization paper will break. So this is a very critical process. A lot of programming, a lot of things are required in this and drive also should be synchronized properly in the road drives. So this is a very important. You can see there each section unwinder will have the different drives. Winder will have the different drives. These are the different drives. All the drives need to be synchronized properly. Because one only paper goes all into this. So this is a very important feature. Modular PLC of 100 model drive is required from here but this is in this line application synchronization is very important. High speed PLC is required in this because it has needs to synchronize properly, otherwise paper will break. And when thickness of the paper is low, that much more accuracy is required. Thickness of the paper is high, and there is force accuracy is okay. But when thickness of the drive decreases, then you have to have to seek very precise speed control in this speed, otherwise paper will break. So this is a very important feature in this. This is the sectional drive. This is the, as you can see, we have done this application from the headstock to the where we do all this goes into one paper only go into this. So we have to keep the speed constant on this. This is the configuration. PLC used to communicate on high speed communication to the drives. There are a number of drives in there, as well as line drives in there. There are standard drives in there. So PLC is an 2-3 HMI or SCADA will use to monitor the system. So this is a very important system. This is the application what we are doing. Control is there and the balance what we are doing Dnyanshree. Then the packaging. And you know the packaging process will be there after that paper is produced. After this, when paper is produced, there is an important process called as the reminder. In this, what will happen? With the reminder, so paper will be cut into the lane, not with the lane, width will be cut according to the width. And there the unwinder will be there, the reminder will be there. So again, synchronization will be there, one drive will be regeneration, whatever in the motor. So there will be DC bus again, same thing will be required in this DC bus communication. DC bus on the DC bus will put all the drives and do this thing. And typical unwinder will be regenerative drum and both the drives are is common application which are required for all the industries. One is the energy saving. This is a very important part of the business and part of the drive system because major. You can see the red part. Any company is getting 70% more than 70% more power will be consumed by motors. that is the reason motor is called as the workhorse of the industry. Any industry you take it, and maximum consumption of the power is 70 to 80% power is consumed by motors. So this is the area we need to focus when it is energy. As you know, the demand of energy is increasing, energy saving is important thing. How we can save the energy? Just you see the common method. When we have to control the flow, either fan flow, blower flow, or the wall. Generally, what we do, we run the motor with this full speed, and you are wall with the wall and damper you are controlling the flow. And there the energy you are losing the energy because you are running the motor with full speed and you are damping it in process. So you are losing the energy, but motor is running at full speed. Instead of that, what you can do? Instead of that, what you can do? You can use the drive, which will reduce the speed of the motor, and you will open the damper or wall fully, and it will reduce the speed of the motor because flow is proportional to the speed of the motor. If you take a pump or if you take a fan. So this is the area you need to focus on this, and you use the drive, reduce the speed, and how much energy you can save with this. There are two examples. One is variable torque application. Variable torque application where flow is proportional to speed and torque is proportional to the square of the speed. Because you can see the graph of fan or graph of pump. You see when fan is rotating at low speed, you require very low current, low torque to rotate at speed. When you increase the speed, that much more current will be to take, and it will require more and more torque. And that is the reason speed is proportional against square, T is proportional against square. In the fan work, any constant torque application like conveyor and other things, this is not the case. When the fan is there, pump is there, there will be square law. So torque is proportional against square. If I multiply both the ways by speed, then you can see N into T, and T is replaced by S square, N is N into T. So power is proportional to N in the variable torque application. So if I reduce the speed by 20%, the power will be 50%. So any of the process, there will be a chance to reduce the speed. So any of the process, even 10% of speed you reduce, you get the power cell more 20%. That is called as two torque. And constant torque also application you can say, but it is not like that. 20% speed reduction, 20% power loss. So you have to focus on the area where the more energy is saved, and that much energy you can save, and that much energy you can use for the other plants. That much consumption will be reduced. So this is the area. These are the applications where you can save the energy, like ID, fan, pumps, industry visibility applications are always there. Any industry text, paper, whatever industry text. So these are the very important feature. And then comes the crane. Any of the industry has a crane. There will be cost tower, there will be longitudinal tower, as well as hoist tower. In this, important is the hoist, because you have to lift the material against the gravitational force. That is okay. That will be motoring. When you have down any material towards the gravitational force, you have the control speed going towards the gravitational. At that time, regeneration is very important because that will be pulled by the gravitational force, and you have to restrict that. And that way, the motor goes into regeneration, and then the regenerative drive is required. And how we are controlling that? There will be winding will be there. DC bus will be there of the drive. Otherwise, what will happen if you go to the regeneration? DC bus will increase and drive will keep on overage. So on DC bus, you can use the brake unit, and that resistance you make the brake unit on. Then all the DC power will be put into the resistance, and heat will be produced. And that will be heat. It will be transferred. So electrical energy will be converted to heat, and it will be lost in this. So drive will not take. But what will happen with this? You are losing the energy, you are wasting the energy in heat switch. So instead of that, what you can do, there will be regenerative drive. That whatever DC is there, that will be again converted, there will be another DC will be there, that will be again converted to AC and fed back to system. So energy will be saved. This is very, very important. And dynamic braking, you have the limitation. 30%, 20% that regeneration only happens. But when there is a regular regeneration will be there, you have to go for the regenerative drive. So there are different applications over there. This is another feature of our drive. Say 200 kilowatt motor is there. So if you have to use the regenerative drive, you have to use the 200 kilowatt regenerative. But in our case, FR exceeds the limit which can fit DC bus into AC, because generally regeneration is 50% or 40%, not 100% regeneration. So that much capacity, 75 kilowatt regeneration unit, you can use it and fed back to the system. So this is very important feature when train application is concerned. And then the power plants. There are two types of power plants: the captive power plant and coal generation power plant. Captive power plants are generally used in the steel aluminum industries, where the power state board power is not sufficient because it is the remote area. So can be the captive power area, the raw material is the coal and gas. And then the coal generation plant generally used in the industry like sugar industry and the rice industry. Out of this captive power plant, this thing, then it will go to the waste heat recovery boilers. Whatever heat is produced, that will go to the water heating process as well as the low pressure steam process. These are the power plants are there. This is the fluoride power plant, and the automation required for the power plant. This is the application 2 into 4 65 megawatt, 65 megawatt power plant we have in this. There are in this also there are two feeders there, two for electricity and one for DC. That needs to synchronize. In your phase, then it receives smoothly transport. You cannot stop the process. So this is very, very important. Then effect, as you know, nowadays we are talking about industry 4.0 and other things, which is called effect. From the shop floor level, basically what is in the effect? From the shop floor level, all the information you should carry from the edge computers, then to ERP and EBS, so that all the information will be there. In this, important is that whatever drives are running, whatever motors are running in the industry, that information should be there, and that diagnosis should be there. Then we can do the preventive maintenance. So this is nothing but a diagnostic process, a monitoring process of this. Whatever process is going on, this is diagnostic. And in advance, if you know that one of the motor is vibrating, then it, down the line bearing will fail. Before it is vibrating, you sense by the vibrator and goes the information, then you will immediately act on it. So major damage will be reduced. So what is the building process happen? Dashboard will be produced for the production and other things, improve the productivity. These all things will happen when you do the effect. All the process information you have, then you can continue with that. Then the important thing is the harmonic mitigation. Nowadays, any of the rectifiers try to use it, they tend to produce the harmonic in the level of 2021, and it will go to the supplier level. So nowadays, governments are giving restriction that from your factory, that much harmonic needs to be above that harmonic is not allowed. So everybody wants to do the harmonic mitigation at the factory, arrange the harmonic at the factory. So this is the IEEE 59 compliance. TDD should be less than 5% according to your transformer capacity. These are the few methods. One is the passive control. In this area, to the right, that will reduce the harmonics. But passive control limitation is that up to 70% of load you can reduce the harmonics. Above that load, below that load, harmonic will not be. Instead of that, active filter will be there. Active filter will be connected in the series, actually, not in the parallel, not like series. So you can add the active filter after the installation, not like passive filter. Passive filter you should put at the time of installation. And active filter goes into the parallel. When in the line application, number of lines are there, you can put the active filter at the initial level, common active filter for all the lines. And further, go ahead, we have the active front end. Active front end where three application where it is used. One is the harmonic mitigation, another is the application which has the regeneration. Normal application doesn't go for the active regeneration. So these are the important mitigation process as such. So with this, I have explained all the presentation of the sectors as well as the special applications what is there in the industry. Then I will explain my company as such, which is in India. This company is initially started by 1870 and 1921 the business corporation. So this is the company and this logo is the same bank, and now 1946 which is the company has been born. and 10%. This is a very big group. 10% of Japan economy is run by Mitsubishi. There are a lot of companies like banks, where some all these companies come under Mitsubishi group. So 10% of Japan economy runs by Mitsubishi, and turnover of this company is 3 lakh crores. This is Mitsubishi Electric Corporation, and this is the Mitsubishi Electric footprint in India. Manesar is the head office. Manesar head office is there, and then Mitsubishi Electric factory. These are the groups. Their energy orders will be there, electronic devices will be there, home appliances will be there, AC of Mitsubishi AC. So these comes under the Mitsubishi. And Mitsubishi factory is a division, factory division, the head office in Pune, where I am working from the Pune factory, and there are going to be sales officers are there all over here, and local more than 100 integrators are there which is working with us. And India, both R&D center. After the Japan, Europe, and not again, both are R&D center of Mitsubishi Electric. So this is the way Mitsubishi is very serious on the India business, and these are the products: PLC, small PLC, big PLC, robotic drives, normal drives, robots, HMI, CNC. Some of the manufacturing in India right now, and it will gradually come from Japan. Manufacturing will come to India day by day. There are a lot of companies in Mitsubishi Electric. So these are the even the LBS, ACE, FCC, all these products are there in India. So this is the last slide of my presentation. This is a new factory of 220 crores in expansion plan, and this is the new factory in Pune, Kalegaon area. We have started, and we are manufacturing started from December 2023, and we are manufacturing a lot of products day by day, not only for India, outside India, we will also produce in India and exported to India. This is the purpose of our factory in Pune, established in December 2023. Further expansion is will start from next 2 years. So with this, I will take my presentation. Thank you very much.
Yes, any question from audience? Any type of the query questions you may ask.
Just any other? Even you can ask the question in Marathi, there is no problem. I will answer in Marathi.
Yes, anybody?
काय समजलं विचारायचं क्वेश्चन असेल तर काय समजलं विचारायचं
सरांचं म्हणणं आहे की तुम्हाला जे काही क्वेश्चन्स असतील तुमच्या माइंडमध्ये तर ते तुम्ही फ्रीली मराठीत सुद्धा विचारले तरी चालतील. अदरवे जे आता सरांनी तासाचं 1.5 तासाचं लेक्चर दिलं त्याच्यातून तुम्हाला काय समजलं ते सरांनी कन्वे केलं. रिव्ह्यू पिरियड the presentation is industry 4.0 is signing. It is not restricted to any one branch. It is common to all. Computer से, electrical से, mechanical से.
Good afternoon, sir. So my question was about Industry 4.0. What are the challenges we are facing for the companies to transform our man-made resources into computer-generated processing?
Please explain. I am not got the question.
Actually, why are we facing challenges to transform our industry into the AI-based computing?
Transformer industry.
Yes.
Transformer industry, see, I have to understand one thing. When you go for any of the application or any of the industry code company, you need to get the information from the machine. Actually, what happens in transformer manufacturing, generally machines are maximum small application. So when you have the information, any of the intelligent component or the sensors, then only you can transfer that information to the computer. The first thing what I try to tell you is that I have told that slide, you will understand what I am trying to tell you. In this, just you see the production shop floor. From the production shop floor, you should get the data that will go to the upper drive. So getting the data, you need to have sensors. Say any motor is there, you want to sense it. It is hitting or it is vibrating or not, or what is the current in this case. So that information, how you can transfer, should have at least drive will be there, or MCC will be there, who can communicate it to the top end that this much current is MCC, this much vibration is coming. Though there is a fluctuation in the current, vibration is not the right one. At least you should have the current sensor. So that information will pass on to the transformer manufacturing. Generally, people are using small machines which now have intelligent component or the sensor. That is the reason first level of the information, ground level of the information, pass to the top level. Then that processing can be done. First level should be there. Initial process should be transferred into the electric information in the communication to the top level, so that further analysis can be done. So that is the problem I think. Thank you.
Sir, one more question about regenerative drives. What are the scope of regenerative drives for us? What can we do for research and innovation in them?
See, there are only few applications where regenerative drive is used. Where the regeneration will be there, motor can go into the regeneration instead of motor. When motor will be motoring, when will be regeneration? I will use the example. When you are rotating any of the say conveyor you are rotating. Rotating means you are moving the motor, it will take care. When you want to stop, say you want to stop, then the regeneration will happen because your dynamic energy will be converted into the drive DC bus, and DC bus will push up, and at a certain level it will drive it, will keep on the board. So regenerative drive, what it will do? On the DC bus, it will tap the DC bus at a certain level, that DC, right? In the inverter, DC will be converted to AC, right? So similar reverse process will happen. The DC will be converted to AC and fed back to the system. So there is a lot of innovation possible in the regenerative drive, because day by day nobody wants to use the energy. Even in the train application earlier, people are using the iron train. There we are using the energy they give for. Now people are going for the EV. Though they are costly. So there innovation scope is there, how we can make cheaper. say one drive, say 100 kilowatt drive price is say 1 lakh, but regenerative drive cost is right now 3 lakhs. So this is not actually correct pricing. That should be in the range of 1 to 1.5 to 1.6. So in regenerative, what are the components we are using? Their innovation is required. More effective component, more efficiency component, power component, power device, power components are required. There you can go for the innovation. And future is for regenerative drive. That is true. Because nobody wants to do the innovation. That is important.
Disabled.
Hello, sir. So, which skills are required so that I can start a career as an electrical engineer in your company?
This is a very general question. Not a electrical engineer or mechanical engineer. First thing you have to do, you should try to learn more. First thing when you choose, you want to choose the job also, or do your own work. Choose the job. See that in which job I will get more knowledge, and where I can work hard and build my career, build my knowledge, then I will build my career. So initial stage of the life, you should see the company where I will learn more and more. You should not see the company who is paying to me more. You want to bring the career, my personal thought is that you should join a small company where you should get the liberty to learn more and more, you get the authority. When you join a big company, there is a lot of limitations will be there, lot of stringent norms will be there. So you will not get that flexible as flexible in a small company. So when you are joining the company, you just see what this company is doing, what is future of this company, and what I can learn from it. And put your best efforts, be loyal to the company, don't think that my relatives are working over now, I will not see my phone, I will not my connect phone. Even today also, Saturday, Sunday, my customer phones come, I have been at the age of 56. So try to understand, you should put your best efforts, best loyalty to the company, definitely you will go to that. That is the only thing I can advise you, as you are coming from the rural area. I also came from the rural area, nearby Sami, my house is there. So only thing what I can suggest you, don't go after the money immediately. Money is required. Look at the first few years, 5 years of your career knowledge, and then after that money will accumulate. So think on the loyalty, think on the what best I can learn from the company. What I do.
So my question was about SCADA system. Right now, SCADA system is not known to us, but can SCADA system be used for the AI applications which are now introduced in Industry 4.0?
Yeah, definitely. SCADA is the main part of actually AI or in Industry 4.0. SCADA is nothing but in the PC. That is the, and you have to create this screen. I can some of the application I will show you how screen is used. I have flashed some of these characters in the process. Whatever there in the process, you can show it on the SCADA, and you can show it on just there each point you can show it what is the temperature of that. So monitoring will become easy. So you know that at this zone temperature is there. So a person will change the temperature accordingly. From SCADA also will change. SCADA is nothing else but the HMI only, which is running on the PC. That is the SCADA, and then in SCADA especially I believe there is a huge scope in the as a career in SCADA. Nowadays there are a lot of companies from HMI they are going to SCADA because SCADA is more flexible. So whatever you want to see on the screen, as per your wish, you can see on the screen. You just have to program accordingly, make the screens, make the diagrams like that, and that will be live in the process. You can see the children process is like this. So same process I can put in the SCADA, and on that you can add tabs. Starts from you can add, and you can see the temperature. You can show the current of the motor, particular current of the motor. So monitoring is also possible. Like AI, you can see monitoring possible, then automatically you can take the action on it. SCADA is very important career. You can see nowadays lot of applications are demanding SCADA because SCADA is nothing but IT type of work. But for the industry, and that has huge scope and huge career. So you can focus on the SCADA wherever you are in career. If you are going there, their company is using the SCADA. Please focus programming on the SCADA. On the sales of the SCADA, there is huge applications. There is there, monitoring is there. A lot of applications where SCADA is there. In each and every application SCADA is there. So SCADA is nowadays becoming trained. Because earlier SCADA was very costly, but nowadays SCADA is becoming expensive. Because a lot of companies have improved their business. So SCADA is another industry where it is a mix of industry plus IT. So SCADA is another good career you can choose and good focus you can take. Thank you.
industries. He has also tried to define the process flow of these industries and where possible the automation solutions are provided by that firm to the reputed firms in India. So let's try to make us understand that where possible automation solutions are provided by using PLCs, SCADA, that drives, EFTs and all. So as far as Sir has defined, the process parameters are quite important in any of the heavy industries. So we should have a knowledge of the process parameters to know the processes in detail before automating the process. Sir has also explained us about the power plants, about the furnaces that are being utilized, about the factory solutions, how we can do it, and how in spite of any government, how multidisciplinary engineers can work hand in hand. Sir has also introduced us to his firm that Mitsubishi India about its origin and how the 10% of Japan runs its economy with Mitsubishi India. Even he has introduced us with the head office and the upcoming plans that are being set up by Mitsubishi India in Pune. And as far as the interactive session by students with their questions were answered by Sir, and definitely there is scope for engineers to work with PLC and SCADA drives and how one can choose their careers if you are looking forward to Mitsubishi India as your career or the career opportunities. So that was really a wonderful and interactive session. So I consider it a great privilege to propose good thanks to all the honorable dignitaries. On behalf of Dnyanshree Institute, I would like to extend my Officer, Managing Director, Dnyanshree Institute, Dnyanshree Institute, Professor S. M. Patil, Coordinator, Student Activities, Dnyanshree Institute. I do extend my thanks to all the faculty members and useful participants for the valuable interaction in the sessions. I do thank the session management team for their dedicated efforts for smooth management of the program. So, with the permission of Honorable Chair, I hereby declare that the Industry Expert Lecture on Automation in Heavy Industry, organized by Student Activity Cell of RWNC, Dnyanshree Institute of Engineering and Technology, Sudara, under Vikasit, Bharat 2047, is over. Thank you.